All right, so this is my first going live. This is interesting. Um, I'm gonna go over the homework due today. So I've never done this, so it's weird. Anyway, so I got this worksheet here, right? So this is due today for you guys at 2 o'clock. It's almost 10, so I'm doing this early, but it's just the time I had. So I'm going to use this piece of wood here as the equilibrium, right? So I'll try and keep this less than 10 minutes here. There's only 8 I need to go through. But instead of more of me on the whiteboard recording my screen and posting another video, it just, I feel like I've done a few of those, and I don't know as if that helps too much sometimes, maybe for some of you. But so anyways, this is what I would do if we were in class together. So here we go. So this side here is the reactants, and this side here is the products, right? So from your perspective. So yeah, so I think that's how this works. I'm a little bit weirded out by this whole thing here because I don't like social media and all that jazz. So so basically, actually, I'm sorry, my brain right now isn't working so well. If you're watching exactly what I see, then this is going to be your reactant. This is going to be your products. But wow, I'm having a moment right here live, so that's kind of funny. So I'm gonna go with my original plan here. I always think it's in reverse. So these are my reactants, these are my products. So here we go. All right. First one, they did for you, right? Add N2, it's going to shift to the right, and then H2 will decrease, NH3 will increase, right? So we have to imagine, I know this is kind of tough because I wish I could write it on a board or something behind me, but we have N2, and you can look at the worksheet hopefully about while looking at this here, or at least write the reaction down, right? So you have N2 and you have H2 sitting right here. And then you have NH3 sitting here. So when it's balanced, it's at equilibrium. So if I add, I'm just going to go over that first one. They give you the answer. But if I add N2, this side's going to go down, right? So we're not at equilibrium. It's stressed. So what does the reaction do? It shifts to alleviate that stress, to go back to being at equilibrium. That's LeChatelier's principle. So the N2 that you just added is going to react with the H2 that's already here. It's going to shift to the right, producing more ammonia. The analogy is this side gets heavier, it goes down towards the ground, and now we're back to being balanced at equilibrium. So that's why the answer for number one is it shifts right. And then if I'm adding N2, right, initially, it's going to react with H2 using that H2 up. So the H2 amount, the concentration decreases. That's why the side gets lighter. So it goes up. The NH3 is going to increase in concentration. I'm making more of it. So that's why it's going to get heavier, right? That's the analogy, and go down. So hopefully that makes sense. So now I can explain 2 through 8 a little bit easier. I don't want to take that long for every single one of these. Again, my videos have been too long. All right. So number 2, I'm going to add H2. So if I add H2, it's the exact same result as number 1. If I add N2 or I add H2, this side is going to get heavier. So if I add H2, I'm increasing the amount of H2. It's going to start colliding and reacting with the N2, and it's going to shift to the right, make more NH3, and this side is going to go down. So for number 2, because we're adding more to this side, it's not balanced. We're going to shift right, make more products. So the concentration of NH3 over here is going to increase. You're going to have more of it. That's why it gets heavier. Whereas your N2, right, it was like this because I added H2. So the H2 reacts with the N2, uses up the N2, so it gets lighter. So the N2 is going to decrease in concentration as this thing shifts towards the products and makes more products. So for number 2, it's going to be shift to the right. N2 is going to decrease, NH3 is going to increase. All right, 3, this time we're adding products. So we add NH3. This side goes down. We're not balanced, not at equilibrium. So the NH3 must break apart shift to the left, shift towards the reactants, make more H2 and N2. So we're taking NH3, breaking it apart, making more H2 and N2. So the concentration of H2 and N2 both increase. The side gets heavier and goes back to being balanced at equilibrium. Now, in the meantime, because you just added a bunch of NH3, it will increase immediately, but then it will start to decrease over time as it shifts towards reactants, making more N2 and H2 over here. So for number 3, we're shifting to the left, and we're going to make more, so increase N2 and H2. That's why it goes down. Okay, we're going to remove N2. So these are the opposite. All right, we're going to remove N2. The side's going to get a little bit lighter. So if we remove N2, we have to, I always teach, fill in, right? If you dig a hole with dirt, right, and you want to fill the hole back up, well, you got to put dirt back in it, right? It's not a perfect analogy, but we're making a hole over here. So we're taking N2 away, right? So it's kind of empty, right? Let's fill it. How do we do it? We take NH3, it breaks apart, shifts towards the reactants, makes more N2 and more H2, right? So the NH3, every time it breaks apart, it's going to make more of both. Even though we just took N2 and we didn't mess with the H2, it's still going to shift and make more H2. It's also going to make more NH2, or more N2. So NH3 is going to create more N2 and H2, shift to the left. This side gets heavier. We go back to being at equilibrium. So for number 4, we remove the N2. This is what happens. That's the stress. So it shifts to the left and it makes more N2 and H2. So again, for number 4, it shifts left and H2 and N2, shifts left. H2 is going to increase and the N2 H2 is increasing and NH3 is decreasing, right? So let me just rip through that again. Take N2 away, this side goes up. NH3 is going to use itself up. It's going to take NH3, it's going to break apart. So therefore, you're going to decrease the amount of NH3. The side gets lighter. NH3 is going to shift over here, make H2 and N2. So my H2 concentration goes up, my NH3 concentration goes down. H2 is the exact same thing. Take H2 off this time. It goes up. NH3 breaks down, makes more reactants to go back to being balanced. So again, my NH3 decreases as we shift left, and my H2 and N2 both increase in concentration. So for number 5, it is shifts left, and N2 increases, NH3 decreases. Number 6, this time we're removing NH3. Removing NH3, the side's going to go up, right? It's lighter. What has to happen? The reactants must shift to the right towards the products to make this side heavier, right? So we remove NH3. The answer is it shifts right. N2 and H2 both decrease in concentration. They both decrease in concentration to make more NH3 to go back to being balanced at equilibrium. So for number 6, we're shifting right. N2 and H2 both decrease because they're going to use themselves up to make more of this to go back to being balanced. Okay, now 7 and 8, 2 temperature questions. One of them you're shifting left, one is shifting right. Here we go. All right, so it's exothermic. So what you guys have to understand, and what I tried to teach in the video yesterday, is that 22 kilocalories, this is an old worksheet. It should be kilojoules at this point, but whatever. You have energy sitting right here. Here's the energy. It's with the products. If the energy is on the right, that means it's exothermic. Energy exits at the end, right? You exit class at the end of class. So at the end of the reaction, that's where the energy is. So that's releasing that energy. It's exothermic. Okay. So if we, number 7, increase the temperature, the way I teach it is like increasing that energy. We're adding more energy. Increasing temp, add more to that 22 kilocalories. So if I'm adding more energy, so instead of 22, let's say it's 122. I add more energy, this side's going to get heavier. So what does it do? It shifts to the left. And if you're shifting left, you're making more of what's on the left, making more reactants, N2 and H2. And if you're shifting left, you're going to use up what's over here, your products. What's on the right, you're going to use up the products. So your NH3 is going to decrease in concentration. It's going to use itself to make more N2 and H2 to go back to being balanced at equilibrium. So for number 7, we are shifting to the left. We are increase N2, increase H2, decrease NH3. And then number 8 is the exact opposite. We have that energy here. We're going to take some of that off. We're decreasing temperature. So this side is going to go up. The exact opposite. N2 and H2. N2 and H2 are going to create more ammonia. So we're going to shift to the right for number 8. And we're going to decrease the amount of N2 and H2. We're going to decrease these two. They're going to use themselves up to make more, increase the amount of NH3 to go back to being balanced. So for number 8, we're shifting right. And we're going to decrease N2, decrease H2, increase NH3. Hopefully that makes sense. I will see you guys tomorrow in class. And this was an interesting experience. Here we go.